you need to wait 1 minute.
Yes, I'm trying to set up the screen. I have some problems.
It's 9:50.
Why I can't have a mirror?
Video output?
Yes, but it doesn't work. Nothing works.
Did it detect your HDMI?
It seems here that it finds the projector. But cannot. Laptop.
Can you do like a
Laptop.
this place?
You don't have the slides on the screen.
Yes, I have them.
Do you want to get Martin's laptop?
Yeah, probably.
Hey, Martin.
Oh, like
Let me try with that one.
Try to use your laptop.
just one of them is
Try a different laptop.
Πού είναι, κάτσε να φέρω το στικάκι. Τι? Πάρε από την τσάντα μου, στο μικρό τσεπάκι έχω το στικάκι. Όχι, σε ένα πολύ μικρό που είναι πάνω. Εκεί κάπου. Thank you. Έχω adapter.
He's got an adapter, bro.
Give me that. Στο μικρό τσεπάκι. VGA.
We've got an adapter.
VGA.
VGA to HDMI. Stop.
Όχι. Όχι, δεν έχω αυτό, έχω το αντίθετο.
So I need your presentation somehow. Awesome.
They hacking themselves.
I just leave this here for future reference.
Όχι, θέλουμε το αντίθετο από αυτό που έχω. Κάμισε το.
At least you have a fun dog wallpaper.
Oh, not that. It has also... It does not have. I'm fucking stupid.
Don't worry.
Well, the dog's still running. I think Andrew needs one for his PhD, to be honest.
Let's try that again.
I'm blushing. Blue. Okay. Guy in blue?
That one.
Yeah.
Perfect.
Yeah. It's not mirrored, so you...
Okay. Okay. Okay, sorry for the delay. I'm Nestoras. I'm gonna present today soapy, a handy hardware interface module for GNU Radio. It's a work that it's a project we developed with George Valdakis there for SDR Makerspace, which is a collaboration between LibreSpace Foundation and European Space Agency. So let's talk about why we wanted to develop soapy. The reasons were that, as we all probably know in this room, there are various SDR devices, and we want an easy way to configure them within GNU Radio. One approach is having a generic block like Osmocom source that provides one. But we believe that it's not so easy for an inexperienced user to configure its device correctly. That is mostly because it's a static block. It may report elements that aren't in the RF chain of the hardware device we are using. So we wanted to improve that. So let's talk about soapy SDR for start. soapy SDR is an open source C++ project to interface with SDR hardware devices. What it actually provides, it's a C++ interface which soapy SDR modules that are the implementation of that interface can provide direct support for hardware devices. That way, it's really simple to create a new SDR module for a new device and configure any new device. Another cool feature that soapy provides is the soapy remote, which can, I'm sorry, that allows us to use an SDR device like it's a local network peripheral. We can have it on a different machine and get the data from the stream through the local network or the network in general. So here starts our work, which is our soapy, which is an out-of-stream module for GNU Radio. It provides a source and sync block that actually wraps the soapy SDR functions that the API provides. Really similar till here. And what we do differently from Osmocom is that we try to have dynamic parameters in our XML blocks, so it's easier for the users to configure the devices correctly. What I mean here when I say that the device is supported, I mean it from the GR soapy point of view. That means that someone has changed the XML file accordingly to understand when the device, for example, a Pluto is on the block to generate the correct fields. So here is just a list of the fields that GRSOAPy provides. It's pretty straightforward. We choose a device, we can pass some arguments, stuff like that. We have our corrections. Pretty basic stuff, I believe. So let's see a little bit our blocks. Here, for example, we have a source block, and we decided to work with a device that uses the imaginary driver that's called FOSDEM 2019. So to do that, we have a soapy SDR module installed, but from our point of view, this is an unsupported driver. So we see here the general tab that has some basic information, and on the RF option tab, we have all the fields that we mentioned before. Okay, so we have here the corrections, we have antennas, gain values, and stuff like that. Those fields, because the FOSDEM 2019 driver is unsupported, it doesn't mean that the device supports all of them. What will usually happen if you try to, for example, try to have a frequency correction and the device does not support it, is that you're gonna see a message that what you're trying to do is not allowed. And the device still works like expected. So when we see soapy with a different kind of driver, for example, here we have an AirSpy, which is a supported device from our soapy blocks. The general fields are the same, but if you look closely here, you can see that we don't have the correction fields anymore, because AirSpy doesn't support those corrections, and we now generate new fields that have a specific gain name, so it's easier to configure them. We could also, for example, change that value to auto, so the automatic gain would be true, and we wouldn't see any of those fields, and the device would use the automatic gain control. One problem with this approach is that we're hiding fields and we're showing new fields every time. That is a problem that doesn't actually come from us. We didn't like that, but GNU Radio didn't allow us to do something more fancy, unfortunately. But it works pretty well. So, another reason we believe that GRSOAPy is a really good out-of-stream module is because we think it's expandable and maintainable easily. We have one XML file for the sync block and one XML file for the source block. And those files, if you see the formatting, it's pretty much we have generated all the fields, for example, the PGA gains or the mix gain or whatever. And what we do is, if you see that the device driver is something we support, show the field or hide the field. So if you open the XML files, you could understand very easily what you have to add to support a new device, for example. Also, as the main block in the C++ implementation, it's a wrapper for soapy API, it's also pretty simple to add new function calls from the soapy SDR API. Also, as I mentioned before, because the soapy modules are independent than the soapy SDR API main code, they can build separately. We don't need to rebuild everything over and over again, so it's pretty simple to create a new module to support a new device that is not even released right now, for example. And we believe that is very important. So, to conclude this talk, we believe that you should use soapy, GRSOAPy, because soapy SDR is a robust API. It's easily maintainable. It's a pretty inactive project. We have some talk, for example, we wanted a new feature and we talked to the guy that contributes to the soapy API. Also, GRSOAPy is a really handy way to configure all of the devices. It's really simple for an experienced user that don't want to mess around with what my device supports or what is that gain. I have one, which one should I put in those fields? What values do I have to put there? And also because we have that kind of abstraction that we just wrap the API function calls, it's pretty easily maintainable because we don't have to mess with the main code. We only have to add new devices in the XML file if a new one is there. So, we don't say that everything is perfect with GRSOAPy. One problem is that not all modules are exactly the same. For example, when I was adding the arguments field, some modules were reading them only when they are making the device, and some other were reading them also when they set up the stream. So we had some problems there. The XML file, it may be pretty easy to add a new device, but it's not so easy if you want to add a new gain, for example. You can mess up some stuff. Also, it's pretty messy with the cheetah and the spaces that you must use for the Python to generate it correctly. So that is all from me. Thank you. Any questions?
The next guy can already set up, and we can take one question. One question? You get a ready. You don't, because you're. What's your question?
Yeah, I don't know about performance.
Yes. Yes, that's a good question. We have some preliminary measurements.